All right, well, I think I'll go ahead and get started here. Thank you for your patience with things. What I would like to do in the next small session is to update you on the progress that the lab has made since our last CATEE conference. And to do that, really the first thing I need to do is to recognize all of the staff and the students that work on the TERP project. And you may not know or recognize these people, but here they are. Many of them are here today. Bob and Yazdani and myself tend to be the people that are out, in the gun sites, so to speak. But actually, we rely quite a bit on the work of a number of people to keep things running, including Dr. Juan Carlos Baltazar, Dr. Albie Silverstein, Vic Reed, Shirley Ellis, Jaya Mukhopadhyay, going across the top there. On the bottom, of course, you all know Tammy from the registration. Patrick Parker keeps the computers running. Second left on the bottom row. Roberto Tovar, of course, is here today. We also work quite extensively with Professor Emeritus Larry Diegelman, who's here with us, Sunlok Do, Chunlu Mao, as well as Sukjun Oh and Min-jae Shin. So it's very easy for me to get up and do what I do because I've got a terrific staff and group that are putting things together and making that possible. So I want to make sure you know who those individuals are. In addition, we have a very good working relationship with TCEQ, Vince Myler, Bob Gifford, as well as the Texas Public Utilities Commission, Kathy Rich, Teresa Harris, and of course Doug Taylor, who you've heard today, and Stephen Ross, who's here from SECO. On ERCOT, we work closely with Paul Waddles, Kevin Hansen, and Warren Lasher. TERP wouldn't be what it is today without this interagency cooperation to get things done. When we call each other, we return calls. When we email each other, we return emails. Things don't happen until you have that kind of agreement between agencies and individuals. So the TERP legislation has proceeded slowly over time. This is an example of that on the right here. The 2001 77th session, 2003 78th session, and 2005 79th session. A series of responsibilities and duties were given to us. And these are example of these. This continued through the 2007 80th session, the 2009 81st session, 2011 82nd, and then up until the most recent session, 2013. So each of the things that you've seen there were enabled to perform responsibilities. We have to coordinate with other entities. This is how, so to speak, the sausage gets made in terms of TERP. And we rely on that process, and we have to work closely with the legislatures to make sure that we're responding to the needs of the state of Texas. How do we actually do the accounting for the state implementation plan or SIP credits? Well, this is an example of that. First of all, it has to be quantifiable. Emissions reductions have to be measured to reduce the emissions. And then we need to have procedures that have been evaluated and approved by the EPA for doing that. The emissions have to be surplus. So this is declared in the EPA 2004 document, which is on the right-hand side there. So it has to be something that's not accounted for in another program. So just because you put forth an accounting process doesn't mean that the EPA is going to accept it. They have to actually look at it and make sure that somebody else hasn't put forward that program. It has to be enforceable as well. So for example, the measures that include the emissions from electricity generation have to be enforceable against a particular source or for another party that's responsible for making sure that that's occurring in the case of energy efficiency and renewable energy, or it can be included under a voluntary measures policy. So these are some of the rules that EPA has laid down. Last but not least, we have to have record keeping. We get phone calls periodically from the EPA, and they want to dip into our registry, or they want to dip into our databases and see just exactly how did we do that accounting, and where's that number, and how can they look at it. So all of that is behind the scenes in terms of doing the accounting for the state implementation plan for NOx emissions reductions. The ESL, of course, is responsible for calculating the NOx emissions reductions. First and foremost for the code compliance, secondly for the green power productions, third for the Public Utilities Commission Senate Bill 7 program, for the SECO programs, which you heard Dub Taylor talk about, and then we've added to that the air conditioner replacement programs because of their substantial impact on the state. In addition, one of the main efforts that we put forward, which is working quite well, and we're using it as a model for other efforts, is our code compliance calculator. So one of the things that we did a number of years ago was to come forth with a free web-based simulation, first of its kind, and still the only thing of its kind in the country, which allows the builders and the homeowners of Texas to actually take the characteristics of their building, enter it into a reasonably simple web page, run an hourly simulation on it, and then get a result back to them. Quite a feat, actually, when you think about it. It's done with a series of screens. So the user comes to the website, they put in information about the various details for the site, they put in information about the fenestration. I can't actually see this on the screen, so I have to look to the right there. The windows, the systems installation, the HVAC system, domestic water heating system, the roofing, the sizing of the systems, computer problems, the energy report. When they're done and they hit the button, okay, it actually runs the simulation and it comes back and it gives them a simple yes or no answer, okay? If the answer is satisfactory to them, yes, in this case, you're at or above code, then they get a certificate. That certificate actually goes in with the paperwork for that house, okay? In addition, we issue a printable certificate that can be printed on sticky back paper and actually put in the electrical panel for the building. Now that certificate comes with a number, and the number is actually a registration in the database that we're maintaining at Texas A&M. So that database then allows us to collect these certificates. Since January of 2014 of this year, we've had 20,000 certificates entered in. Since the beginning, we've had almost 100,000 certificates. Those certificates are primarily in the counties that you all know, Dallas-Fort Worth area, Houston area. It's the bulk of them, those 5 counties right there. Tapers off significantly after that. So it allows us to actually look at these certificates on a granular level, where they are across the state, or in aggregate groups of counties, that sort of a thing. So we can ask questions, for example, what's the average seasonal energy efficiency ratio? Well, in this case, we can look by county, by region, and we can see that we're actually doing a little bit better in terms of the state. We can then take that, dial it back into the calculations, and put it forward for state implementation plan credits. In addition, we can take that information and we can answer some of the questions that we get. One of the things that goes on around our lab consistently is the phone rings. And when we get emails and when we get the phone ringing, people are asking questions. Sometimes a simple question can be very hard to answer, okay? For example, why are there differences between the results of the different simulation programs? Well, you can say to yourself, who cares? Well, the reality of it is it matters a lot, because sometimes you can run one simulation program and it says, my house passes. And you can run another simulation and it says, my house doesn't pass. That's really frustrating for the code officials and for the homeowners. So they get on the website, they email us, they call us, they want to know why. So we're taking a look at that. Secondly, we've had people say, look, I don't care who you are and what you're doing. If you don't put it out there so that we can look at it, it's not helping. So they said, why don't you publish the input file to your simulation code so we can run it ourselves? So we've done both of those things in a pair of reports that are hanging on our website. On the first one in particular, we've been working very closely with the 3 individuals, particular agencies, that have developed these other simulation programs. And we've said, look guys, we've got to get these things aligned. We've got to take a look at how things are agreeing or not agreeing. So some of the preliminary results that we've done have shown that actually we do get good agreement when you run the same house with a lockdown set of characteristics and compare the results. So when you look at, for example, the differences between the energy gauge software, the REM rate software, and the IC3 software, those are the 3 biggies in particular. You see, when you run a house that complies with the code, you actually get fairly good agreement. Okay? However, when you go into the weeds and you start digging around a little bit, you realize some of these characteristics agree. For example, if you increase the size of the house, you get similar results. But when you decrease the size of the house below the characteristics that are collected by the National Association of Homeowners, well, you can see on the little graphs to the left right there, you start to get some variations on that. Okay? And by the way, it gets worse on some of the most important characteristics for the house. For example, the window-to-wall ratio, the insulation levels. So even from my perspective, you got to ask yourself, what are we supposed to do about this? Okay. Well, the reality of it is we've been working carefully with the Texas Home Energy Rating Organization, Texas HERO, because as a laboratory, we have our own code. We sort of have a vested interest in it. So it's not like we can pull together the group and say, your numbers need to equal ours. We needed somebody like Texas HERO to pull together these 3 entities, in fact, actually 4 entities, to make it work. So Texas HERO pulled together Energy Gauge, REM Rate, and the Pacific Northwest National Labs that produces ResCheck. And they said, guys, we can't have these differences in the programs. If one house is entered in one program, it's got to agree reasonably well across the other programs. If it doesn't, we need to know what the differences are and where those differences are, so that we can explain that to the code officials and the homeowners. Because when we have uncertainty and when we have questions, we're not getting the job done. So we've been working closely with the Texas Home Energy Rating Organization to resolve some of those differences, and we're coming to fruition in terms of actually getting some agreement in the codes. Some of us have had to change the things that we're doing. We've had to lock down some of the parameters so that we get reasonable results between the 2. On the second issue here, we've been asked, can we publish the actual simulation input file that we use? Okay. Well, the answer is yes, we have. Okay. And here it is. We put together a simplified residential model. It's ugly, I know. But it has all the characteristics of an average house. So in other words, it has the window-to-wall ratios, it has the wall sizing, the roof sizing. This is how you do a code compliance simulation. Okay? Some of you like to eat sausage, some of you like to make sausage. Quite often the people that eat sausage don't know how you make sausage. Well, this is how we make sausage, so to speak, when you do a code compliance simulation. And furthermore, this is what the input file looks like. So if you want to see what are we simulating, what are we not simulating, it's out there now on our website. In addition, we've been asked simple things like, okay, your simulation program tells me I'm going to save some energy on my building, but will my utility bills go down? Well, we actually have been looking at that. We've been looking at the same builder in the same subdivision over a series of 10 years now, okay? And the answer is yes. The bill actually goes down, okay? We published that in a report with the American Society of Heating, Refrigeration, Air Conditioning Engineers in 2014. In that report, we've looked at actual utility bills, College Station, it's easy to do. We've been working with the builder. We actually get the utility bills because it's a municipal utility, and we dig in and we look at these. Okay? Across these utility bills, you can see that, yeah, there's a signal there, okay? But there's some variation over time, so we have to have a way of normalizing that. Okay? In general, when we look at that, we see that we can separate out those houses that were built before 2001, those houses that were built from 2001 under compliance of the 2001 IECC, and the 2006 IECC, which included the SEER 13 air conditioners. And what we see in general is that the results in the electricity savings are on the order of a 20% drop with each of those two steps. Okay, and this is what it looks like when you do a sliding average. So the top line, the houses that were built before the code. The second line is in compliance with the 2001 IECC. Third line was when you put in the more efficient air conditioners. And in general, it agrees with our simulations. So that's the kind of sanity check that we're doing that says, yeah, we do have some certainty that this is actually working. And we're not afraid to look at utility bills over dozens of houses and actually see if the job is working. So, as we've looked to other things as well, we've seen, for example, that we've had changes that we need to make to the website. Our current website, you come in through the web page, you run the IC3 software, it gives you a result. We've had other people come to us and say, that's not enough. I want to run your software from a distance through an API, so to speak. So that's what we've developed, an applications programming interface, which allows a third party to come in and so to speak, come behind the scenes, run the knobs behind the web page and get the results. This will allow then the modeling that we do to be accessible to tablets and iPhones. It'll also allow other people to have their own software with their own interface and run it in the background. And we do that, of course, using an XML input-output to accomplish that. So we're trying to move ahead as the technology changes with these. Over time, we've also been asked to measure the impact of the code. We've done that with SingleFamily. As we've gone through the various different codes, the 2000, 2001 supplement, 2003, 2006, 2009, 2012, and 2015. You pull all these together, you do the mashup with the total number of buildings that have been done, and now you can start to quantify savings. Okay? Those savings have equaled about $1.4 billion in electricity that didn't have to be purchased because the houses are more efficient, $1.5 billion in demand, billion. Okay, I've got 1,400 million, which is 1.4 billion. Okay, 1,500 million, which is 1.4 billion. Okay, so I'm sorry, I'm converting in my head in speaking the converted number. Okay, total is just short of $3 billion across the state in electricity and in demand that didn't need to be purchased. Okay. This is for an additional cost of only $1 billion. Not bad, okay? We're already getting our money back from the investments we've made over the 10-year period. Now, during that time, we've had a substantial reduction in the number of megawatts that didn't have to be produced, and it's equal to more than one power plant. And we've released at least 50,000 cars from having driven on the road, the equivalent for that. So if you think the traffic, I mean, it's not like we're going to put those cars back on the road, but this is the crossover in the pollution reductions. So it's a substantial savings. If you want to look at the details, we've got a draft report on the website. So as we go forward, we get requests from legislatures, we get requests from others. We put those requests down in a report and we put it out there so that we can use that as evidence that the program's working. In addition, we've seen, of course, that there is this issue with water. You know, yes, there's an interrelationship between water and electricity on the front end and on the back end. Okay? When you use electricity, you use water to make that electricity. Typically, when you use water, you use electricity to deliver the water. Even when you send your sewage waste to the sewage treatment plant, you got to use electricity to treat that. Okay? So we're starting to look at some of these crossover things. For example, within our program, we've identified about 1.4 million megawatt hours in electricity savings. Okay? When we run the numbers using a conversion of about 430 gallons per megawatt hour, we can see that that saved about 600 or more million gallons of water. Okay? So that's water that didn't have to be pumped because the electricity didn't have to be delivered to these homes because they're more efficient. So these are some of the accountings that we do when we actually have the numbers at the granularity level across each of the counties. Okay? When we look at renewables, we see that we've got the usual suspects, solar, solar thermal, solar PV, we've got hydro, we've got biomass, landfill gas, geothermal, and of course the 500-pound gorilla in the state is wind, okay, because it's had such a huge impact. Each of these things need to be looked at individually. In the case of the wind, we actually track each plant, each wind farm, okay? We get the 15-minute data from ERCOT, we mash it up and we do the accounting. So within the ERCOT region, we've got projects within the Western States Coordinating Council. We have wind farms in those regions as well. And then in the Southwest Power Pool, we have wind farms showing up in that area as well. All these come together. We've got 90 wind projects in our database, 38 wind projects that have been announced that'll be coming online, and they've actually retired one of the wind projects. I don't know where our retired windmill goes, but we have one project that's been retired. All of these go into the mashup when we do the accounting for wind. Okay? Over time, when we add these up, the numbers look something like that. Okay? We have to go across the gigawatt hours that are produced, the megawatts in terms of the capacity. We have to look at the peak, not only within ERCOT, but actually within ERCOT plus within the whole state level. When we do the accounting on that, we see that we've got about 11.4 gigawatts in the ERCOT region, 11,400 megawatts, 12,400 megawatts within the Texas region right there. The new peak generation was about 3 million megawatt hours per month, okay, occurring in the most recent period. Statewide then, within the last period, was about 32 million megawatt hours, which is almost 10% of the power that's generated within ERCOT, and that's incredible. So during this period of TURP, the wind industry has responded, and it's made a difference in things. And furthermore, if you look across the bottom of the graph right there, what you see is that during the dog days of the summer, we're still getting a significant contribution from the wind, and it's making a difference there. So not only do you look at the top of the graph, which occurs in the winter and the spring, you all know that when you live here because the wind blows, but during the dog days of the summer when the wind is not blowing, we're still getting a significant contribution from the wind farms. So it's working. In addition, we get questions, for example, from EPA and TCEQ, things like, okay, do the power production levels from these wind farms actually degrade over time? So wind farm by wind farm, we actually have to look at the data since we've got it. We look at the data in the beginning period, okay? We see that, if there's going to be any degradation between the beginning with the most recent periods here. In this case, we see in the beginning of the data that we have for this particular wind farm in Indian Mesa, 48 megawatts, okay? End of it, 58.8, so we actually don't see any degradation, we see an increase. When we expand that out to all the wind farms across the state, we look at what's there in the beginning, what's there over time. We see that roughly 15 of these sites are running at full capacity, 100%. Right? About 16 sites are running in the 95 to 99% range, and 7 sites are running in the 95% range. So we can look across the sites, across the years, we can answer the degradation issue. This is important for TCEQ when they go back to the EPA and they say, yeah, we put wind farms in, they work, and they continue to work, and we can measure that and answer that question. Okay? In addition, we have to cast backwards. So imagine you're fly fishing, only you're not fly fishing out in front, you're fly fishing in back of you. Okay? That's what it means when we have to actually do the NOx emissions reductions calculation. So we take the data from 2013, we cast it backwards to the base year in 2008. We do that through a wind normalization effort. Okay, so we actually have to normalize the numbers, build a model, and drive it with the wind data for 2008. In this case, about a 12% reduction for the ozone season period, that's the OSP, okay? And for the annual measured use, also a small decrease in the energy that's recorded. So each of those are part of the process of recording it and then casting backwards into the base year. Okay? Now we have to take the electricity that we've recorded and we have to turn it into air pollution. So to do that, we have to do the process of mapping all of the different power plants in the state and how do they deliver the power to the different areas in the state. So we have to locate those traditional power sources, thermal power plants, hydroelectric, nuclear. We have to cite then where the renewable sites are coming in, connect those up to the transmission lines, connect the transmission lines down to the distribution stations, and then run those to the residential, commercial, and industrial customers. When we then jiggle the branches in terms of the residential commercial customers, we want to see how it actually jiggles the savings back at each of the power plants. Okay? We do that with a model that's sort of like a brick. So you have a number of pages in the model and you have threads going through the different pages, and that's how we do the connect up on the calculation. That's done with a thing called EGrid. Okay? EGrid is the EPA's Emissions Generation Integrated Database that actually has the NOx per megawatt hour, CO2 per megawatt hour, that sort of a thing. It's published for 4 congestion management zones in the state. These are located, as you can see, on the map right there. At the end of the day, it looks something like this when you march it around the state for the west zone, the north zone, the south zone, and the Houston zone. So not only do we have to track where things are happening, we need to know spatially where they're happening, where the counties are, who's supplying that power, and then we have to track it back to what's the NOx or the CO2 emissions rate from each of those power plants. Okay? This is what it looks like, for example, for the 2010 Ozone Seasons Day NOx emissions values coming within the EGrid for the state. Okay? Once we have that, then we can take the megawatt hour reductions and we can forecast that into the future then to tell us what the reductions are going to be. We use a 3% forecasting factor to give us from the current 2013 through 2020, okay, and we can see we're going from about 9 to 11, almost 12 reductions. These are tons of ozone on a ozone season day, okay. We also look at renewables in the same way. Okay? And in this case, when we look at renewables, you can see from the green bars there, which are the wind. Okay? We have the numbers so we can actually run the calculations for that. But we also need to look at the tip of the numbers right there because that's how small the other renewables are compared to the wind. Okay? You have to keep that in mind. The wind's contributing a lot, but as we start to grow these other renewables, the other things are growing as well. So you can see, for example, we have a good amount of growth in the solar, which is increasing slowly but surely on the bottom. The landfill gas is relatively consistent. Okay? The hydro, of course, varies as we have various amounts of rainfall on the state. And we've seen, interestingly enough as well, the biomass varies a little bit from year to year. So there can be a little jumping around as some of these natural resources depend on a resource that can be more or less in a given year. All these things need to be factored in and accounted for, so when we get questions from the legislature about, I want to do more of this or I want to do more of that, we can say, okay, yeah, this is reliable, that maybe not quite as reliable, let's put a safety factor on it. Okay? We need to know where those sites are, so we have to actually find where those sites are. In this case, the 3,200 solar photovoltaic sites, the 19 biomass projects, the 26 hydro projects, the 32 landfill gas projects, and the 286 geothermal sites. Each of those sites then need to be accounted for and factored in to the accounting process. In addition, we have to pull in the numbers from the other agencies that are participating in the TERP program. In this case, the Public Utilities Commission, which are responsible for the Senate Bill 7 programs and the residential energy efficiency programs. We have to factor those in and then project out into the future. We do the same thing for the State Energy Conservation Office, savings and projections, energy efficiency programs for school districts, government agencies, private industrial and residential energy consumers, as well as SECO's programs, energy conservation projects reported by political subdivisions. We'll do the accounting and then we march it out into the future. We have to have an assumption that these programs are here. If there's degradation, we need to factor it in, et cetera. This is what that looks like for SECO. All of these things come together across the different state agencies, right? So these are the agencies that are participating there. Each of those agencies then report their emissions reductions, their power reductions. We do the conversions for our own program, the Public Utilities Commission, the State Energy Conservation Office, the ERCOT wind projects, and then of course the SEER air conditioner, SEER 13 replacement programs. Those then get accounted for in a totalizing fashion, but because we have the data at a granular level, we can look at it by county, by program, by SIP area. We can look at it by ERCOT region, or we can look at it within surrounding regions, you name it. Because we've got it in a database, we can dial in the numbers, separate it out, and do the accounting. Over time, this is the final graph that gets posted typically. We do the roll-up, so to speak. We can see that, for example, the code compliance with the current accounting process for 2013 is about 0.6 tons per day. For the Senate Bill 7 program, about 1.5 tons per day. SECO's political subdivision program was 0.5 tons per day on an ozone season day. The wind power, 9 tons per day, so that's the large salmon-colored bar there. The residential air conditioning retrofit program, about half a ton per day. So a total of about 12.2 tons on an ozone season day. We project those out with our assumptions to 2020. We do the roll-up, and you can see then things equal out to about 18, excuse me, let me go back here. It's not going back. Okay, so we do the rollout to 2020, and we get about 18.3 tons. So these are the numbers then that go forward to DCEQ and to EPA, and that's the connect up that we do between the programs and the credit that we're getting for things. Last but not least, we publish these things, and this is an example of our webpage right here, so you're welcome to come and look at the different reports. They're published by year. Okay? And I can say that if you're having trouble sleeping at night, these are a wonderful way to get yourself to sleep. Okay? I want to end with this. If you want to have a visual of, is it working? This is it. Okay? This is from NASA. This is the air pollution levels from 2005, the darker levels, through 2011, the lighter levels. You can look at what's happening in Texas. Is it working? Yes, it's working. Is our job done? No, our job's not done. Do we need to stay on top of it? You bet we need to stay on top of it. We got more people coming. We've got other issues popping up. But when we put our heads together, we can make things work. Thank you.